Good afternoon from me. It's lovely to see you all again. For those of you who don't know me, I'm Helen Martin, one of the directors of the Gateway Alliance. Thank you for joining us for session 2 of our Science Leaders Network CPD sessions this academic year. Thank you to Elle for joining us again this week. Really looking forward to a great session. Just before we start, just a couple of housekeeping bits and bobs. Please do put your camera on. It's lovely to see your faces, no matter where you are and what's in your background. It's great to have that interaction, just so Elle knows that there's somebody in the room that she's talking to, and can feel sort of your interaction in that way. Whilst the session's running, if you can keep your microphones muted. If you have got contributions to share when it's open in terms of your thoughts or contributions, please do unmute your microphone. That's absolutely brilliant. It'd be great to hear from you. Do use the chat as well. There'll be opportunities for you to be able to share your thinking and share questions in the chat. So you should have a menu bar at the bottom of the screen with chat on there. If you click, and then you can type into that. Make sure you type and it says to everyone, and then everybody can see that. We're going to hopefully have a couple of breakout rooms that I'll pop you into, which will hopefully give you an opportunity to have some smaller group discussions with colleagues on the call. So I'll explain more about those as we go, but it'll obviously be similar to last time for those of you here for the last session. And I think that's all. We're due to be finishing at 5:15, so just so you get that in terms of an idea of timing. But I'm going to hand over to Elle now, and we'll start the session. So welcome, Elle. Thank you for coming back. I'll see you.
Thank you. Thanks for having me. Hi, everyone. Hope you've had a good day today. Okay, so today I have been asked, I think we've got the same group of people as last week, but for those of you who don't know me, my name's Eleanor Atkinson, and I'm a consultant with Primarily Science. I'm also a PSTT, that's Primary Science Teaching Trust College Fellow, and a Primary Science Quality Mark Hub Leader and Assessor. I also work with the Ogden Trust, which is a brilliant physics charity. If you've not heard of them, they've got lots of free CPD and free physics resources for your school. So I'm also a consultant for them. Okay, so our session today, I've been asked to do something on progression in working scientifically, and also I'm going to look at how we can enhance the science curriculum a little bit later on. Please use the chat function. I can see someone's just jumped on chat. I'll try and read it. No, I'm unable to. Is that anything I need to know, Helen?
No, it was just Anne-Marie saying she's on an old laptop, so the camera and mic are playing up, so she'll do her best. She said, but if you chat, then that's brilliant, so don't worry.
Okay, just do the best you can. That's all we can do. Okay, so I did send out a little request for some things that you might need today, but please don't worry if you've not had time or you've forgotten. I know what it's like. Things get busy. We're going to start our session today by looking at a few pupil science books or floor books. And the reason for this, I thought we would start our session by looking at the 5 types of inquiry. So if you have some science books, that would be great. Also, you're going to need 3 pieces of paper, and I want these pieces of paper to be the same type, style, size, colour, because we're going to do a little investigation using that paper later on. You can use a stopwatch. If you don't have one of them, you should have one on your phone, maybe, be able to time something, or you can just count in seconds. You'll need a notebook and a pencil as well to take some notes. And also, it says you'll need this link for this drive. If you've not got that, I'm just going to try and jump on chat. Stop share a minute. For some reason, it's not letting me see chat when I'm sharing my screen. So let's try here. Okay, everyone, I've just shared a link with you for a Padlet. This Padlet has all the resources that I'm going to be talking about today. Can I ask you all to click on that and have that open in a separate tab during our session? And I will go back to the PowerPoint while you're doing that. Okay, hopefully most of you have been able to do that. So we're going to start off by looking at progression in working scientifically skills. And the first thing I would like you to do is to try and discover where you're starting from. Monitoring's been really difficult with the COVID situation being as it is at the moment. If you have managed to get some pupil science books from a few different classrooms or from your own, can you identify the 5 inquiry types in those books? And I'm just going to give you a few minutes just to reflect on, what do you feel is going really well in science at school at the moment? And what are you struggling with, or what do you need some help with? So either take a few minutes to look through your books for some examples of the 5 inquiry types. And if you don't have them, jump on chat and let me know, what do you think is going really well in science and what are you struggling with? Thanks, Louise. So identifying and classifying, you can see well across Key Stage 1 and Key Stage 2. Did you see any examples of pattern seeking or a fair test or a comparative test? So Harriet says the use of vocab and other subjects being a priority after COVID. So the use of vocab, I'm guessing, is a positive, and other subjects being a priority after COVID is a negative, I'm guessing. Anyone else? Could be better with pattern seeking maybe and research, okay. Positive provision of science across mixed stage classes, that's tough, yeah. Okay. Okay, thanks everyone for that. Just gives me an idea. Staff feeling open-minded to new resources that might support them, and they feel swamped. Oh, bless. Fair testing's good in upper Key Stage 2, that's good. When you say they feel swamped, Jo, is that with everything else, or do you mean they feel swamped with the new resources? You can unmute yourself if that's easier.
Yes, it's that really. It's that science is, not that it isn't a priority, but there are a lot of logistics in the day that we wouldn't have had before, which I think are beginning to sort of, and as things are adapting, like we've just started to tentatively go back to the hall for lunches. So the structure of people's days has been thrown out. So all of that stuff about managing, sorting resources and quarantining them before they go between year groups, and I think it's all of those things. I mean, people are trying really hard, but I'm mindful that we have to go gently with each other at the minute, I think, don't we?
I agree. I think it's just the constant change, isn't it? It's layer upon layer upon layer of change, and we're adapting all the time. It is really difficult. And of course, everything's suffered as a result, and science will have done as well. But if you can still see examples of science inquiry, then that's brilliant. Okay. Yeah. I'm going to carry on now. Thanks everyone for commenting. I just want to share with you this website. It's called Inquiring Science for All. It should be on the Padlet I've shared with you all, and this has been created by Manchester University and their network of teachers. And this just really supports your staff in using all 5 types of inquiry, because some staff won't even be aware that there's 5 types of inquiry. So when you log on this website, it shows different drop-down menus like observation over time, pattern seeking, And they've created these lovely bright icons that teachers use in planning, on displays, in children's books. I've seen some teachers use this in their planning. They highlight when they're doing an observation over time in purple, because every inquiry type has a different colour. So that's another way that they can be used. When you go on this website, they have a drop-down menu that looks like this, and it shows from year 1 to year 11. You just click on your year group and it gives you lots of ideas based on that topic of how you can carry out an observation over time. So if you identify through your monitoring activities that maybe this isn't being done so much, you can just direct your teachers to this website. Okay. So I want to just give you some time to think. You know, we're always hectic, 100 miles an hour as teachers, as leaders of subjects, and we hear all these different terms bandied around. So there's the 5 inquiry types, there's working scientifically, and there's science enquiry, and you sometimes see that spelt with an I, inquiry. I want you to all just have a little think. Are they the same or are they different? And I want you to try and explain how or why you think they're the same or different in chat. Yeah, Louise, I would agree with that. We do work scientifically throughout all the 5 inquiry types. What does everyone else think? Do you think they're the same? Do you think they're different? Have you never really thought about this before? Yeah, Katie, that's a brilliant explanation. So science inquiry might be answering a specific question, and working scientifically is how it's done. That's right, Katie, brilliant. And in fact, Katie, the 5 inquiry types could be the method of answering that question as well. Okay, so Kayla says the inquiry types are ways of gathering data through working scientifically. Science inquiry is answering questions by doing this. They're brilliant answers, everybody. We don't often get chance to just think about all these different terms are bandied around, and I wonder sometimes how confusing this must be for teachers who aren't science specialists or science leaders, who aren't exposed to this all the time. And we might interchange and use all these different terms with our staff. So it's just worth thinking about and really unpicking that for ourselves. Okay, so there are 3 aims in our primary science curriculum, and that's that children develop scientific knowledge, but we also have to develop their skills, which is the nature and processes and methods of science. And we do this through different types of inquiries, and that allows them to answer scientific questions around the world, about the world around them. So lots of you answered that, lots of you were correct in answering my question. So our national curriculum is split into the knowledge aspects and the working scientifically aspects, what they know and what they do. And science inquiry is how children learn or apply the knowledge and the skills, or the skills. So working scientifically skills are needed to carry out science inquiry. Now the PSTT, the Primary Science Teaching Trust, have produced this poster that you can find on their website, and it's called the Working Scientifically Cycle. And the Primary Science Teaching Trust have split the skills or looked at the skills in great depth, and that this is the skills that they say our children need to develop in order to work scientifically. So we've got asking questions, and I've included a link for this on the Padlet, so don't feel like you have to make copious amounts of notes. You should be able to find this quite easily on the Padlet I shared. So we need our children to be able to ask questions, make predictions, set up tests, observe and measure, record data, and interpret and communicate results and evaluate. So this is a cycle. Now, lots of teachers use this poster in their classrooms to tick when they've carried out a specific skill with their class. But if you look in the centre of this cycle, we've got the plan, do, review cycle. So some of these skills we would cover whilst we're planning an investigation, some whilst we're doing or carrying out an investigation, and some whilst we're reviewing. And as you know, primarily science have created these plan, do, review boards. I don't know if you all have these. I've included a link. You can download these for free on our free resources. If yes, Louise, I will make sure you get a copy of the PowerPoint as well. You can download these resources for free, or if you want to buy huge, great big laminated posters for your classroom that you can write on with dry white marker pens, then we charge about £30–40 for that. So I'm going to go through how you can use this to support the cycle, the working scientifically cycle. And we would use these planning boards for a fair test. And this is where you might need your 3 pieces of paper. This is something really easy that you can do with children. I'm always looking for COVID-friendly investigations that we can do now. So this would link in really nicely with Year 5 and their knowledge aspects of air resistance. So, first of all, with 3 pieces of paper, we could ask a question linked to air resistance and gravity for Year 5. And we could, oh, sorry, just let me press play on that. We could ask, how will paper fall? How will these different pieces of paper fall? What if we change the shape of the paper? Lots of children have some misconceptions around things that are heavier fall first. So if we have 3 pieces of paper that are exactly the same and we just change the shape of them, this helps to dispel those misconceptions around that. So we've got a flat piece, a folded piece, and a scrunched up piece. And using the post-it plan board, how does the paper fall, we could then discuss with our class variables that we could change for this. So you can feel free to jot some down in the chat function. What variables could we change? I've already mentioned one. We could change the shape of the paper, was the one I mentioned. I've put type of paper up there now as well. Can you think of anything else? The material, yeah. The size of the paper, yeah. Anything else that you can think of? Variables we could change. The thickness, the height that we drop it from, yeah. Anything else? Thanks everybody who's interacting. I really appreciate that. Sometimes I feel like I'm just sat here in my kitchen all on my own talking to myself. Damps. Katie, you've put damp. So yeah, we could make some of the paper damp, I suppose you mean, yeah. So let's see what I thought of. I thought of the type of paper. There's, you could use tissue paper, you could use a thick sort of card, you could use, I'm just going to have to stop sharing again. It's gone funny on my screen. You could use tin foil, for example. There's lots of different types of paper that you could use for this. The shape of the paper, so you could have heart-shaped, triangle, square, oblong. The size of the paper, someone else mentioned that. The colour, kids always mention colour. If it's red and red's your favourite colour, that might be the fastest to fall to the floor. How we drop the paper. If we give it a little shove, that might help it. So how we're dropping the paper is important. And the thickness of the paper, I think someone else mentioned that. So once we've got the variables we could change, we need to think of variables we can measure. I came up with the time it takes to drop. And I also thought we could just observe which one lands first. So when you're using this board with a class, you need to take the post-it notes and move them down the sheet. So for this particular investigation, we will change the shape of the paper. We're going to have a scrunched ball, a folded piece, and a flat piece. So we will change the shape, and we could measure using a stopwatch the time it takes to land. So our question is, if we change the shape of paper, what will happen to the time it takes to land? And to make it a fair test, we need to keep as many variables as possible the same. Now, one that isn't on here that should be on here, and someone mentioned, was the height that we drop it from. I think Louise mentioned that. Okay, so this is a fair or comparative test where we change one thing, we measure or observe something else, and we try to keep as many other variables as possible the same. What I'd like you all to do now, you can carry out this investigation if you want. You can fold and scrunch some paper and drop it and see what happens, see if there's a noticeable difference. If you drop two at the same time, a scrunched and a flat piece, you could have a little play with that and see how different it is. But what I would like you all to do is to predict what you think will happen by drawing a graph, so a predictive graph. This is really useful to help your children to think about the next step in an investigation, which is data collection. Okay, so have a little think. What we're changing is the shape of the paper, and what we're measuring is the time it takes to drop. So have a little go. I'm going to stop share now. Have a little go at drawing a graph, a predictive graph. Yeah, you can use the paper helicopters as well. You can change the wing size of that. You can do that with the paper spinners. When you've drawn a predictive graph, can you hold it up to your camera so we can all see each other's predictions? Let's see what you think.
When you say a graph, do you mean like a bar graph or more like a line graph?
Well, that's what I want you to try and work out. I'm not going to tell you. You have to try and work out what type it will be. So we want our children to be as independent as possible, and drawing a graph is a skill in itself, something that you could teach in maths lessons, but then get them to practice this skill. Thanks, Louise. That's fab. Louise is super brave. Come on, Camilla. I can almost see it. Come a bit closer, a little bit closer, Camilla. Oh, it's tiny. No wonder I can't see it. Thank you, Camilla. Anyone else want to share their graphs? Go on, Judy. Fabulous. Deborah, well done. I can see yours. Go on, Katie. Oh, Katie's all technical. Wow. Okay, brilliant. What's that fandangled equipment you've got, Katie? That's brilliant. Chris, fantastic.
So handy. It's my iPad.
Okay, I'm going to share my screen again. Thank you, everybody who participated. That was lovely. Scroll down to where we were. Okay, so predictive graphing. We don't always have to do predictions that are written or verbal predictions. I think this is really useful for Key Stage 2, upper Key Stage 2 especially. So hopefully you've got something that looks like this. I've not labelled it and I've not given it a title, but I've moved the post-it notes, as you can see. I've moved them here for the shape of the paper where I've got scrunched, and I predicted maybe about 1.3 seconds, and folded 2.4 seconds, and flat 2.8 seconds. And I've drawn some rough bars there. And this poster, the do section of the primarily science post-it note section, just helps you to model as a teacher how they might collect the data. So you can just collect data using the table and get them to go and independently create a graph, or you can use this with just a small group of children who might need some support in their math skills, or you can print this sheet off and give it to individual children or small groups of children to work on together after during their investigation. Okay, and then the next bit is the review. So when we change the shape of paper, what will happen to the time it takes to drop? And you all correctly predicted using bar charts there, or a bar graph. When we have numbers, when what we change is the numbers, and words, what we change was words, the shape of the paper, and what we measure is numbers, that will result in a bar chart. When we have numbers on the horizontal axis and numbers on the y-axis as well, numbers and numbers will result in a scatter graph or a line graph. So you can stick some of the children's prediction graphs up on the review board here, and you can get them to describe how their prediction supports the results. You can get them to explain why, and then you can get them to explain why using scientific language. So these are in order of progression. Some children will describe, others can explain, and others can explain using scientific language, and that's the gold standard that we're looking for. And then you can go on to ask if there's any unusual results. So a gust of wind from the open window could have come in just as you were dropping your folded piece of paper, and it could have blown that paper sideways, and then it took much longer to land than what it should have done. You could talk about repeat measures in that case. And then you could ask them for a conclusion. So the smaller the surface area, the faster it was to fall to the floor, there was less air resistance. So our plan do review boards hopefully will support you in your class with fair and comparative tests. Just going to see if I can read a chat. Nope. Yeah, we could have done averages. You could have done repeat measures and averages. That's right, yeah. I'm going to ask you all, just going forward, if you want to speak, please unmute your mic and make a comment. For some reason, my laptop won't let me screen share and read the chat at the same time. I don't know why it started doing that. Okay, so back to those working scientifically skills that we looked at from the Primary Science Teaching Trust. These were on the working scientifically cycle we looked at a few minutes ago. If you look at these skills here and you think about the process that we've just gone through with a plan, do and review, how many of these skills did we cover in this one investigation? If we were to do that with our class, how many of these skills have we covered?
All of them.
Yeah, all of them.
Yeah, all of them.
Yeah, I agree. So I just wanted to share that with you. That's a free, you can have the electronic versions of those as totally free. Again, it's only for fair or comparative tests. We do have a Key Stage 1 friendly version, which is Discovery Dog, which I'm not going through today. We don't have enough time to go through that, but it's just a younger pupil, more friendly, little cartoon character. It's not as formal looking. Okay, I'm going to ask to breakout rooms in a minute. On the Padlet, you should see this card sort activity. What I'd like you all to do is click on the card sort activity on the Padlet before we go into breakout rooms. I'm just going to give you a couple of minutes to do that.
Would you like us to download it?
Yes, please. It should be, I'm just sharing the Padlet link again. It should be a Google Drive document. And then what I'd like you all to do is when you're in your breakout rooms, if one person could screen share this Google document, it is our working scientifically skills that have all been jumbled up. You'll have an empty document and you'll have all of the Key Stage 1, Lower Key Stage 2 and Upper Key Stage 2 skills all jumbled up. And I would like for you all to engage in a professional dialogue and try to put them in the correct Key Stage 1, Lower Key Stage 2 and Upper Key Stage 2 columns. Does that make sense? So it's a collaboration. Okay, so Blair is on the iPad. Don't think I can view both at the same time. That's okay. Hopefully someone in your group will be able to screen share for you and you'll just be able to. Don't worry, Anne-Marie, if you can't access it, someone in your room definitely will be able to. Okay, just those who can, download it. Okay. Helen, please could you put everyone into breakout rooms of maybe 4 people?
Yeah, absolutely. I've got mostly groups of 4, one group of 5. So
that's fine, that's perfect. Thank you. And I'm going to give you all 10 minutes to work on this, okay?
If you're in a room and nobody can access the resources, please, you can either, there's a button that says ask for help and then we'll know, or just come back into the main room, leave that breakout room, and then we'll be able to come and help you and move you around a little bit. So I'll press the button now to open the room. You should have an invitation come up on your screen to invite you to join the breakout rooms. And then there'll be a 60-second countdown at the end when you know that you'll be brought back into the main room. So we'll see you in about 10 minutes. Thank you. There we go. Welcome back, everybody. I think everyone's back in the room.
Hi, everyone. I've put the answers up on the screen. Hopefully you can see that now. And the reason that I did this is because it's not often that we get a chance to just really study the national curriculum. We're far too busy doing 800 million different other things in our school day. So this helps us with progression as well. What's expected in Key Stage 1, what's expected in Lower Key Stage 2, and what's expected in Upper Key Stage 2. And if you are looking for ways in science to support or challenge your pupils, this is the area that you can do it in the skills section. One thing I wanted to point out, and I don't know if you noticed this, in year 3 and 4, they have a lot more in the evaluating, recording, a lot more description there. There's a lot more in Lower Key Stage 2 than in Upper Key Stage 2 in terms of evaluating. So I hope you found that useful. I hope there was some professional dialogue around there and it wasn't too difficult for you to do. I'm going to move on now. The plan, ASE and PLAN, which stands for Pan London Assessment, they created these free documents, which I'm sure many of you have heard of, but they have the progression in working scientifically skills. These are totally free. You can access these online. And the reason that I'm just showing you these is that it gives you a little bit more detail. So in bold, we have the national curriculum statements under the key stage headings there. And then we've got some more description to support you in what that might look like. So this is all about asking questions, the page I'm displaying. You can see the bullet points there give a bit more detail. This might be useful for you. If we look at progression in just one element or one key skill across the school, this might be useful for book monitoring. If we just look in recording, for example, in Key Stage 1, children have to gather and record data to help in answering questions. And then we've got additional detail there. So that might be videos, photographs, drawings, labelled diagrams or writing. and they can record their measurements using prepared tables or pictograms or tally charts. Whereas when we move into lower key stage 2, we do see tally charts still and we see tables still, but we've got bar charts now mentioned, and you can still give them templates there if they're required to support them. They also start to record some classifications in lower key stage 2 in year 4. And then as we move up into upper key stage 2, we see that they're labelling scientific diagrams and they're drawing more line graphs and scatter graphs now. So this will help. I think these ASE plan documents really help you to know what it looks like, what it should look like, what age-related expectations look like in each key stage.
Helena, I've just Joe's just popped on the chat. Is this on the Padlet, a link to this resource, or
it should be? If it isn't, I can certainly send you the link for this. But this is a free resource on the Plan website.
Fab, thank you.
Yeah, I think it is. It's the 4th one along on the top.
Thank you. Okay, so what might that look like in real life? So in key stage 1, gathering and recording data to help in answering questions. So we're not testing them and their ability to draw a table or a tally chart. So you just give them those pre-prepared tables. So these children here are testing out some absorbent materials, and all they have to do is write, is it absorbent, yes or no? They can just write the words yes or no, really easy for them. They might want to show what they've discovered in an investigation using simple pictures and simple sentences. You might want to give them a pre-prepared tally chart like this if you go on a bug hunt, and they can just make small marks. And they can turn that then into a pictogram by using simple pictures or diagrams. So that's what it could look like in the classroom. And so as it supports us in the ASE plan documents, children record their observations using photographs, videos, label diagrams, pictograms, tally charts, block graphs. And they could use simple prepared tables and sorting rings. There wasn't an example of everything there, but just to give you a flavour. So in lower key stage 2, in the area of recording and presenting evidence, this is what the national curriculum says, that they've got to present data in a variety of ways. That's very wishy-washy. It doesn't really give us much detail. But they can record findings using simple scientific language, drawings, label diagrams, keys, bar charts and tables. And this is what it might look like in the classroom. So again, we're not testing their ability to draw a table, so we can provide that for them, but they might start to create their own bar charts here. Obviously, it will depend on the ability of the child. And again, it's perfectly acceptable to give the children some pre-prepared tables to help them. We want to know what their findings are in science, not if they can draw an accurate labelled table. They might as well use sorting circles or Venn diagrams. So this is the additional detail that we get on the plan documents. I'll let you guys read that. Okay. And in upper key stage 2, we're going to look at, this is what the national curriculum says, that we're looking for increasing complexity using scientific diagrams and labels, classification keys, tables, scatter graph, bar and line graphs. And this is what it might look like in the classroom. So this time the children would be expected to be able to draw a table themselves and include the information in there. The measurements are a little bit more complex, the numbers are a little bit more complex. We'd expect more detailed sentences in terms of their conclusions. And we might see still Carroll and Venn diagrams happening. We might see the use of ICT in creating classification keys, bar charts, line graphs, and a very detailed here, labelled scientific diagram with lots of scientific vocabulary. So hopefully that's giving you a flavour of progression in just one small skill in the working scientifically element. So hopefully you have some ideas about progression, what that might look like. Hopefully I've signposted you to some free resources that are going to support that in your classroom. And hopefully you've learned something today and you might want to change something as a result. If you have, let me know in chat if there's something you found out from that, if there's something useful, if you're going to change something, if you're going to do some monitoring as a result of that, let me know in chat.
I think I'm definitely going to do some more monitoring. Although I lead science, I don't actually teach it. I teach it sometimes, but I have a good overview of what everyone's doing.
Yeah, it's good to do some monitoring when we're allowed to monitor the progression. Yeah, I mean, especially if you've got some external bodies like Ofsted coming in, or it could be a school improvement partner. The worst thing that could happen is that they open the books in year 2 and there's far more detailed bar charts in there than there is in year 5 or 6. So it's just making sure that staff are aware of what the expectations are. So in year 5 and 6, we want to see more detailed written conclusions, more scientific vocabulary. We want to see more line graphs. Well, we should only be seeing line graphs really in upper key stage 2. So the ASE plan stuff is really useful, I think, to support teachers with that. Okay, try and share my screen again. Okay, so that was my bit on progression. I'm going to go in for some fun stuff now, how to enhance our science curriculum. And the first thing I want to let you know about that's coming up really soon is the Great Science Share for Schools that's starting on the 15th of June. Hopefully you've all heard of this before. It's quite a new, it's a new thing really. It's not been going for that long, maybe 5 years, maybe less. But this year, the exciting news is that I'm allowed to share with you all is that Brian Cox is supporting it, and there is a free event for 5 to 14-year-olds on climate and environment on the 15th of June. So all you need to do is register your school, register your class, and you can get involved with that for free. But there's tons of other stuff going on with the Great Science Share. I've got a little video. Got a little video here. Hopefully.
Hello, fellow explorers. I am Richard Garriott. I am an astronaut and an aquanaut. I have both traveled in space aboard the International Space Station, as well as I recently returned from a deep submersible trip to the bottom of the Challenger Deep, the deepest place on Earth. My journey into STEM actually began when I was quite young, when I first was getting into school in what we called kindergarten, my very first year of school. I was introduced by my mother to science fairs, very much like the Great Science Share. And starting then, I began to do projects every year for the science fair that we had in my school, and I participated literally each of the years that I was in school. But I can easily say that is where I built my love for STEM. if I had to think about the biggest STEM problem I would like to solve in my lifetime, I would say it is helping humanity learn to live beyond the Earth. You know, Earth is the place where all of our species have been born, but in the great span of time, I think that we will spread humanity throughout the galaxy. And one of the things I really hope to be able to help do is to help us build colonies that are permanent and thriving off of planet Earth. And what do I think is important about the Great Science Share? Well, I would go back to my journey in STEM, and I would say it is science fairs and events like the Great Science Share that help inspire me. It did help inspire me when I was young, and I hope that it inspires you just the same. So I'm looking forward to seeing the projects that you all put up in this year's Great Science Share.
So the Great Science Share has created a range of videos like that to introduce your children to different scientists, and there's scientists from all different backgrounds and all different types of sciences. There's women, there's BAME scientists, so really useful to start a discussion and just to build some science capital amongst your children, to get them thinking about careers in STEM, which is, we have this huge STEM gap, don't we, that we're trying to encourage children to see science as valuable and important and relevant to their lives. So the Great Science Share is to encourage children to ask questions and to independently investigate them. And it can just be one day that you want to spend on it, or it starts actually next week. They've got medical mavericks, they've got a doctor who does all kinds of investigations into the human body. For example, the first week is about clean air. So the doctor looks at lungs, and he has a camera inserted in his nose down into his lungs, and the biopsy is taken. But there's lesson plans there to support an exercise lesson where children find out if exercise in fact impacts their breathing. And there's also a lung capacity investigation. There's lots and lots of different activities that you can get involved with, and lots of free resources there. So I highly recommend the Great Science Share for schools, and it's totally free. There's also, if you're interested in food and farming and growing vegetables, there's a farmer who creates videos every week and talks to the children. He's really engaging and fascinating. He shows the children what's happening on his farm. So linked to that as well, there is some climate superheroes from Farm Venture, and they've created a challenge this year. They want children to create an invention, an innovation, or an idea to help British farmers to care for the environment. And the winners will present their ideas at a prestigious event at the Houses of Parliament, and you can win £1,000 for the school to spend on STEM or outdoor learning equipment. So all entrants will become certified farm venters, and they'll receive a reward pack. So that's everybody who enters, including a certificate and a mini prize. And you've got until the 31st of May to enter this competition. So that might be something that you want to get involved with your school or your class. If you go on the website, which should be on the Padlet, it's really child friendly. There's lots of cartoon characters, and hopefully your kids will find that really engaging. The next thing I wanted to share with you is the Primary Science Teaching Trust have created so many fantastic resources on their website, but this one I just wanted to point out to you all. British Science Week this year fell at a time when we were welcoming children back after school closure, and I know that lots of schools found it impossible to do their usual science weeks because of that. So if you've decided to delay your science week, or you're going to have it a bit later on in the summer, this summer term, the PSTT have created these whistle-stop science weeks. You pick a theme, you engage the children, and then you shout and share. So you share what you've been doing there. So lots of resources to support you with that. This is another free resource. It might not be one that you want to look at, but I just thought I'd flag it up. It's free, and it's to help primary pupils make sense of COVID-19. And it's just about linking this in a primary friendly way to the science curriculum. It's been created by Jane Turner, who's the director of the Primary Science Quality Mark and also Snap Science, but that's totally free as well if you have an interest in that. Now, this is about to close in 2 days, so you may not have time to do this, but the British Science Week poster competition, this is last year's winners. We've got early years there on the left, and then lower key stage 2 and upper key stage 2. They're the winners from last year. So it doesn't have to be, I mean, if you look at the early years one, that's lovely, some words, some pictures. The lower key stage 2 one is amazing in the middle. I don't think I could do that. Absolutely amazing. But you do have a few days, so you could still be in with a chance of winning something. And I wanted to just make you aware that it's National Gardening Week coming, well, starting tomorrow actually, from the 29th of April to the 5th of May. And the RHS has a school gardening website with hundreds of resources, things that you can do in the school gardens, projects you can do in the classroom, all around soil, plants, life cycles, insects. There's some amazing activities there. So that's another free resource that I just wanted to highlight. We also have coming up, it's not 117 days to go now, it's on the 21st of June till the 27th of June, we've got the Insect Week, National Insect Week, and there is a competition to go with this as well. But it's a photography competition, this one. So just getting your children outside with iPads, can they find some insects? Can they take some photographs of them? But this website contains some really lovely resources. I'm going to share some lovely videos that can raise science capital.
An entomologist is a scientist who studies insects and their lives. Some entomologists may look at how insects behave. Some study where insects live. Some look at insect pests and the diseases they carry, and others try to describe new insect species that are discovered. There are even entomologists that help solve crimes by studying dead bodies and the insects that live on them. Entomology is the study of insects and their relationship to humans, the environment, and other living things. Entomology is a very old science, dating back to the beginning of biology in ancient Greece. Humans have had an interest in the insect world for centuries, thanks to pests and the need to produce food. Many people have jobs as entomologists, but even more people study insects as a hobby in their spare time. Whatever insects an entomologist works with, they are helping us to understand the little things that run the world.
So that's just one example of a whole suite of videos that they have on that website. But that would be a nice thing to get involved with on sunny days, get the children doing a bug hunt and some science around that. Okay, I've included the link to this as well. So the Ogden Trust have provided a magician, Dr. Matt Pritchard, with some funding. And as a result of that, he's created this free resource. It's free to download called Sparking Wonder. And it's an ebook, so you can just download it as a PDF. And it's got lots of really fascinating science investigations that are almost like magic tricks, but there's a science behind them. So if you want to spark some awe and wonder in your class or in your assemblies or schools, this is a really useful resource for that. And it's totally free. The Linnean Society as well, if you're doing classification in year 6 or year 4, they also have a little competition that they're running at the moment. Even adults can get involved. So they're asking schools or pupils to create a new species and to send their new species with their name and the picture of their species, its scientific and common name, and a paragraph giving the reasons for its adaptation. So this is, I think, more linked to year 6, and a description of its habitat. So there's a prize and a competition for that as well, if that falls in with what you're teaching at the moment in year 6. And last but not least, I don't know if you've heard of this before. Lots of people I talk to haven't, and it's an amazing free resource. The website's called Practical Action, and they've created, based on real life problems in the world, such as pollution, plastics, they've created sets of teacher resources, lesson plans, PowerPoints, pupil activities that are totally free. So this one in particular starts at looking plastic and how we can reuse plastic, how we can make something useful out of junk. Another really good one they have is called Ditch the Dirt, and that links in really nicely with year 5 sieving and filtering dirty water to find a solution for the millions of people around the world who don't have access to clean water. So there's lots of really good stuff on this website. And that, I think, is me done. So to make up for being 15 minutes over last time, I am 15 minutes under this time. If you have any questions, feel free to mute yourself or type it in the chat. Oh, Kaylee's entered a competition. I don't know which one though. Can't see the chat when I'm sharing my screen, Kaylee. Which competition have you entered?
Sorry, that was the British Science Week one. We still did British Science Week when we came back as a sort of mental health type science thing to come back to. So we still entered the competition.
Brilliant. Well, good luck. Fingers crossed. I hope you win something. Thank you so much. Thank you to you as well, Taylor, Harriet, and Marie. Thank you.
Thank you so much. Sorry. Is there any other questions? I don't want to cut in if people have got questions or want to hang back and have a chat anyway, in terms of if there's anything specific that, you know, you want to explore a little bit further and pick Elle's brains while she's here and in the room. Obviously, it would be much easier to do this if we were in person. So perhaps it's worth taking the opportunity to take that time whilst we're here. I'm just going to pop in the chat a link to the feedback form, which you should get emailed to you as well shortly. Your feedback's really important to us and we want to develop this network for you. So please let us know what areas of practice in terms of science that we can revisit moving forward. I've just picked up about the Padlet and I will, well, on the members area is the link to the Padlet from the last week's session, along with the recording and the slides from that. And I've put the Padlet link on from this session as well. That's already up there. And as soon as Elle sends me the slides, I'll put those on and the recording from today as well. So that should be all in the members area. So I sent you an email last week with a password for that. So you log into your normal account on the members area, and then it's just in the curriculum CPD subscription. You click on science and then pop that password in. If you have any problems, just get in touch with us and we can talk you through that and walk you through that. But huge thank you, Elle, for being with us last week and this week and for sharing so many different ideas and practical resources and things that we can go and look up and use in school. Thank you, colleagues, for engaging. It's wonderful when you get involved in the session. It's so hard when it's on Zoom. We know that it's frustrating, that you'd love to be back in a room so we could have some more interactive conversations. But thank you so much for giving it a go and interacting today and engaging with the breakout rooms and some of the activities. It's been brilliant to work with you. Please do hang on if you've got any questions or want to chat to Elle, that would be great. But if not, as I say, I'll send you the email when the resources are all available, and have a lovely evening. So thank you.
Thanks, everyone. Bye. Take care. Bye-bye.